These are the video notes for lesson 3.1 to 3.3. Okay, lesson 3.1, we're dealing with variables and exponents. When you have an exponent raised to another exponent, like we do in the numerator of the first example, we're going to multiply the exponents. So this 2 on the outside is going to go for the a and for the b's exponent. And the a's exponent is 2, so 2 times 2 is 4. And the b's exponent is 1. 1 times 2 is 2. And so that's how you simplify that. What we're going to do next, there's 2 ways to do this. We can subtract the exponents because a to the 4th and a have the same base. So 4 minus 1 is 3. And the exponent for b would be negative 1. And from our last lesson, negative exponents, we're going to write the reciprocal. A cubed stays in the numerator because it doesn't have a negative exponent, and then b to the first will go down to the denominator. Another way to do this is at this point right here, which is a little tedious, is to write out all the a's and the b's that you have. And you're going to divide out 1 for 1 for each one, which would be a cubed over b. So either way, but this will be a better method for much more complicated examples. Okay, moving on to the example down below, 4 stays the same because it's not being raised to any exponent. This exponent 3 is for the a and the b, so the a will become 9 and the b will become 3 for the exponents. Next one, the 2 will be cubed because it's in the parentheses, and a will become to the 6th power, and then b will become to the 4th power. Again, 2 times 3 is 6, 2 times 2 is 4. This is going to be 4a to the 3rd over, b to the negative 1st over 8. 2 cubed is 8, and 3 minus 4 is negative 1. And then I'm going to reduce the fraction and place the b in the denominator. 4 over 8 reduces to 1/2, so that's why I have 1/2. Okay, you can try the 2 examples on your own. So the numerator for the first one will be 2 squared, which is 4. A to the 4th, 2 times 2 is 4. B to the 6th, 3 times 2 is 6. And c squared because 1 times 2 is 2. The denominator stays the same. I'm going to subtract the exponents, so I'll get 4, a to the negative 1, b to the 5th, and c to the 0. 4 will stay in the numerator, b will stay in the numerator, a moves to the denominator, and the c goes away because c to the 0 power is 1. Okay, our next example, this negative sign is being raised to an odd exponent, so you know your final answer will be negative, so just keep that in mind. And now I'm going to continue with the problem. So this would be x to the 9th, y cubed, z to the 6th. I multiplied the exponents. And the denominator, which is also being raised to the exponent because it's in the big parentheses, will be x cubed and y to the negative 12. So I'm going to subtract my exponents. 9 minus 3 is 6. And this you have to be really careful for. This is not going to be negative 9, which is what a lot of students will write. This is 3 minus a negative 12. 3 minus a negative 12 is 3 plus 12, which is 15. So this will be y to the 15th power. Be careful not to write negative 9 because that's going to be wrong. Z to the 6th is going to just stay in the numerator. And then I'm going to put a negative sign because of the reminder that I have here that the final answer will be negative. Okay, so for the next lesson, there are 2 ways to do these problems, but unfortunately, I have to show the harder way, which is factoring out a GCF, and I'm going to show you what that means in the first example. So in the numerator, we're going to factor out x squared, and I have x to the 5th plus 1, and the denominator stays the same. So to explain that, when you have a binomial which in this case we do, and both of the bases are the same, the GCF will be the base with the smallest exponent, which in this case is x squared. So that's why I wrote x squared here first. So that's where that comes from. To obtain the x to the fifth plus 1, what you do is you take the original part of the binomial in the problem and you divide it by the GCF. And that's x to the fifth, and that's where my x to the fifth comes from. Then you take the second part, x squared, and you divide it by the GCF, and that's 1, and that's where that 1 comes from. For those that do recognize this, if you distribute this will be x to the 7th, and that would be x squared. That gives us the original problem, so you know that you did it correctly. So let me get rid of all these arrows. And I'll get rid of that too. Okay, so what happens now is this is a monomial, which I'm going to divide out with a monomial. Anything over itself is 1, so that's where that rule comes from. And then I'm just left with x to the fifth plus 1. You cannot, I repeat, don't do this ever. You can't take this x squared and divide it out with this x to the fifth, because that x to the fifth is part of a binomial. You can only cross out monomials individually like I just did, so don't be tempted to do that. Another way to do this problem, which I think is easier to understand, I'll show you right now. However, on the next slide, you won't be able to do it. So I'll just show it to you. For the easier problems, if you want to, what you could do is you can, hold on, you can take the original problem and write it separately like this and reduce this way to get that. Now some of you might be at this point going, well, why didn't you show that in the first place? The next slide, you won't be able to get away with that. But because this problem is very simplistic, you can. So please, rework this method because, like I said, next slide, won't be able to get away with it. All right, so let's do the next one using the GCF way. The greatest common factor between 4 and 2 is 2. And the GCF between x cubed and x to the fourth, as I said before, is the smaller exponent. So when I take this 4x cubed and divide it by the GCF I found, that's going to be 2. So 2 goes in here. I'm going to copy the sign that's there. And I'm going to take this part, 2x to the fourth, and divide it by the GCF, and that's going to be x. All over 4x cubed. Okay, I'm going to use a different color here. So this x cubed is going to divide out with this x cubed. And this 2 is going to reduce with the 4 to produce a 2 in the denominator. So my final answer is going to be 2 minus x over 2. Again, do not, I'm going to highlight. Don't reduce this 2 with this 2. You're not allowed to. Again, the reason, this 2 is a monomial. This 2 is part of a binomial up on top, so you're not allowed to reduce those. Okay, so try these two. So for the first example, you can actually use that simplified method that I talked about in that last slide, where you separate it. I'm going to show you the GCF method. So this is going to be, the GCF would be 3a squared, and then we're left with a squared plus 3. And then the denominator will remain the same, and then these two monomials will divide out, and I got a squared plus 3. So here we go. This is the example that I was referring to, that you can't separate it. You're not allowed to. So the only other method that we're forced to use is the factoring method. So the numerator stays the same. The denominator, the GCF here, is 2x squared. Notice one part has a y and one part has a z. When you have two terms like that have different variables, it can't be a part of the GCF because the C in GCF stands for greatest common factor. So After I take the first part and divide it by the GCF, that's going to give me a y. Copy the sign. Take the second part, divide it by the GCF, and that's going to be 2z. And now I have this. So what I can do is reduce the 4 and 2. I'm going to divide out the x squareds, and then I'm left with 2yz in the numerator and y plus 2z in the denominator. Okay, I do not know how many times I'm going to have to say this. Do not simplify within the complex fraction. I'm not going to accept it. I've said this plenty of times already. So here I need to see some side work. This is a little complicated. So this part, I'm going to write a to the fourth divided by a squared over 16, which is a to the fourth times 16 over a squared. And then I'm going to reduce this, and I get 4 over a. Oops, that looks like a 9. That is a 9. 4 over a. So this part right here became 4 over a. And then I'm going to bring down this times a over 16. I'm going to reduce the a's, reduce the 4 and 16, and I'll get 1 over 4. This is required. Don't do that. Like, some people are like, I don't even know how to do it. Like, don't do that. No. Not accepted. Sorry. Okay, I'm going to do side work for each part. So this is 2 divided by x cubed over 4, which is 2 over 1 times 4 over x cubed, and that's 8 over x cubed. So this first part is 8 over x cubed times whatever the second part is, x over 2 divided by 3, which is x over 2 times 1/3, which is x over 6. So x over 6. Okay, I'm going to reduce. There's going to be 2 left on the bottom here. And then 2, 4, 2, 3. So this is 4 over 3x squared. Remember, we put numbers in front of variables, so don't write x squared 3. If that reduced this part, if this part confuses you, and I think it might for some of you, you can use that simpler method I was talking about. If you have one x on the top and you have 3 x's on the bottom, this one x will divide out with that one, and I'm left with 2 of them. Notice I wrote 2 here, so you can break it up like that if that helps you, but that's up to you. Okay, definitely need some side work for this problem for sure. For the second part, I have 4 over ab squared divided by abc. So this is going to be 4 over a squared b squared. I'm distributing the exponent there, times 1 over abc. And that's going to become, nothing reduces, a cubed b to the third c. Okay, so back to the original problem. I'm going to write from my side work what I got. Okay, so this is going to divide out with this. There's going to be 1a left on the bottom. This is going to divide out with this. There's going to be 2 b's left on the bottom. The 2 is going to reduce with the 4 to give a 2. And that's it. So the numerator is just 2. Denominator is going to be a b squared c squared. And again, you should, not again, I think this is the first time. Make sure your variables are in order. Don't write c squared first, just because a c came first in the problem. That's proper formatting. Okay, first fraction, side work. I have 2x squared plus 6x cubed divided by 2x squared over 3. So this is going to be 2x squared plus 6x cubed over 1 times 3 over 2x squared. Now, this is why that previous lesson was taught. I need to factor out the GCF for this guy right here. So the GCF there is 2x squared, so that's going to be 1 plus 3x. Just double checking my work, yeah, okay. And the reason why we did that, I know it's a lot of work, we're going to divide out these 2x squareds. And then what I'm left with is a 3 parentheses 1 plus 3x, which is, I'm going to distribute to 3. 3 times 1 is 3. 3 times 3x is 9x. So all this stuff became 3 plus 9x. And then I'm going to put this over 1. Then it says to multiply with 1 over 2 plus 6x. Here I'm going to factor out the GCF again. So that's 1 plus 3x over 1 times 1 over 2, 1 plus 3x. And I'm glad that I did, because what happens is the 1 plus 3x's will divide out, and I'm left with 3 over 2.